Good day, welcome to Great White Retro. I'm Gord Fessick, and this is the Little16 version 4 project by Para. When we last left off, we got the Commodore 16 portion of this working, except for getting color video, which we did manage to get, and I'll explain how we managed that in this episode. We'll try to get the user port working today, and we'll explain the troubles we ran into with certain devices that plug into the user port, and then we will get the SID audio working. And with any luck, we'll have a 1984 class machine with better color graphics than a Commodore 64, and at least the same audio as a Commodore 64, maybe a little bit better. Let's get her done. When we last left off, this machine was working, but only giving us grayscale video. So let's address the video first. Para helped me work on this. In fact, I went and gutted the composite portion of the video circuit just to narrow down the problem some. I forgot one very important part. This adjustable capacitor down here in the clock circuit was all I really needed. What I can do is I can adjust the video using that tuner on here, using that adjustable cap. So what I'll do is I will turn it until it turns color. There we go. I'll note where my position is. Then I'll go all the way the other way until it changes to black and white again. There we go. And then I'll kind of split the difference. That seemed to work, at least for PAL. What I found for NTSC was that the margin was a little tighter, but I was still able to get it. Now the TED chip is unique among Commodore chips in that all you have to do is replace the crystal and the firmware to switch between NTSC and PAL. Okay, so we have Open Handtech open here, and we've got our scope probes hooked up. The yellow line is the luminance signal, and the blue line is the chrominance signal. And what we're trying to accomplish is to get the luma signal to be at or just under 1 volt peak to peak, and it's kind of hovering right now between like 0.9 and 1.09. We'll take that for now. Likewise, the chroma signal is where it's supposed to be around 0.3 volts peak to peak. Right, it's hovering there between 290 something and 303 something. On the board, I had to do a little bit of etching. There's a couple of jumpers on the back side that I will highlight, and they had to be etched away with the Dremel because they are shorted from the factory. And those jumpers either enable or disable the use of these adjustable resistors here, these potentiometers. They're listed as RV1 and 2. I'm going to try to find the recommended values for RV1 and RV2 just based on this here, but it'll require me desoldering these. But what we can do is we can adjust this until our luma signal is just around 1. There we go, right? And our chroma signal is just around 3. So it's hovering between 2 and 3. Okay. And as I do this, I am noticing that I'm getting less artifacting on my S-video output. It's pretty smooth right now. It can go a lot worse. With the recommended resistor settings and leaving those jumpers closed, both of those signals run pretty hot. That might be fine for a typical monitor, but if you're looking for the best picture quality, you'll want to be able to adjust these. So I'm going to explain to cut 2 jumpers on the underside of the board, and then you're going to omit all these missing parts. If all you want is S-video, you can do this. If you want S-video and composite, well, you've got a couple choices. You can fill in the remaining components, or you can use an S-video to composite adapter off of this cable here. Okay, bottom, top. Now, this is not going to work as it is, as we're missing the pieces that we need. But let's at least get our diagnostics to the point where we were. Alright, now, user port's not going to work. That's fine. We'll just make sure that everything else works as originally intended. Okay, so we're doing the RAM test. We're testing the ROMs. Keyboard is not working, at least it's looking for a 6529 that doesn't exist. It seems to think that the joysticks are okay though, and that everything else is behaving. Now let's get these ICs populated here. I would like to thank Radwell International up in Ontario. They're an eBay vendor, and I'll link to them, because these guys were able to provide some 74LS654 chips on short notice. These are difficult to find. They are an obsolete part, but they are still commonly available, and if you wanted to order like $250 US worth of them, you can get them from Rockwell Semiconductor in the United States. They will remanufacture obsolete parts. I can't do that, not unless I'm going to put together a big, large order of little 16 kits for you all to assemble. Speaking of such, I have a community post rather, asking whether you would like to have kits available. And I will link to that poll in this video. Please consider responding to it. If there's enough support to order parts for enough kits that can justify bulk ordering this part, then I will run a Kickstarter where I will pre-order all of these, and all of my backers will get a LittleSixteen kit with every part available from DigiKey, with the exception of the 8501 CPU and the TED chip. You'll have to source these yourself, but everything else I can get from either DigiKey or from Rockwell. So we're going to need this parallel port IC. I think that's enough to get the user port working. Let's give that a shot. Ah, there we go. It seems to think the parallel pins on the user port are okay. I could, in theory, plug in a user port adapter and play Attack of the Petsky robots on here now. So we have that much. Now let's get the serial port working. Now if you remember from my last +4 impromptu repair video, I had a bad inverter that caused the serial port test to not work. So we'll make sure that works. We're first going to install an original Commodore Business Machines UART here. And then we're going to install one of these inverters, 74HCT04. Yeah, that's a hex inverter. Okay. This was the part I had to replace on that +4 to get the user port fully working. So let's install that and see if the serial port loopback also works. Okay, there we go. Serial port seems to be okay, or the RS-232 port rather. So the UART is working, the inverter is working, yep, and Diag264 is happy. Now you don't have to use an original Commodore part. Western Design Center makes a 6551 part that'll also fit in this spot. There are also many third-party manufacturers of this part. It's a pretty common one still. Before we get to the really fun stuff, the SID chip here, I need to point out some safety notices here. There are different components you need to connect depending on whether you're using a a 6581 part, or the slightly newer 8580 part found in the Commodore 64C and some newer machines like the 128B. The voltage regulator has to be different, that's why I put a socket in here. Some of the resistors and capacitors have to be different as well. If you're using an 8580, you will also need to install a variable resistor for digital audio playback. And you'll also need to enable the digital audio fixes. The 8580s were not nicely implemented on the 64C, and as a consequence, games like Impossible Mission with some speech would have very, very low volume speech. So to fix that, you install this resistor and you enable this jumper here on the 8580 part. If you're using an original 6581 SID, you do not need to do either of those things. Also, third-party alternatives to the SID chip are not currently supported. The reason is the TED-based machines use a slightly different clock frequency than the original Commodore 64 machines do. As a consequence, audio pitch is going to be slightly different. If you were to use the exact same SID register settings on a +4 with a SID card or on the LittleSixteen, the pitch will be slightly lower. But even bigger than that is that the third-party replacements will not work well with the slightly slower clock that the LittleSixteen board provides, and that's also going to apply to any of the third-party SID cards that work on a +4. One other neat thing is if you have a SID chip installed, you can use analog paddles. That's what this pin header here is for. And there's also an extra register IC you can use to support a regular joystick off of this port as well. So we're first going to install our voltage regulator here, and check this very carefully. You're supposed to use a different part depending on whether you're using a 6581 or an 8580. I am using the part meant for a 6581. There we go. And I have gone to the trouble of putting a heatsink on the back of this. This does seem to fit inside the Commodore 64C case. Now I've got a selection of 2 SID chips. Alright, and with those 2 parts in, we should be good to go. Okay, let's fire this up. Oh, it did come up. Okay. All right. I'll just do some basic checks and then I will change the camera over. Sounds good so far. It's a little on the quiet side. But I've already turned this as far up as I can. Yeah, that's as far as it goes. This is what I meant by that slightly different pitch. I think they're playing the original SID tune, but it's off by 2 semitones, or basically, if it were playing a C, it would actually sound like a B. Kind of like the difference between an NTSC and PAL Commodore 64, come to think of it. Well, this isn't a real copy of the Great Guiana Sisters. This is simply a scrolling and audio demo that I can use as a test for the SID chip in here. And the SID gets pretty warm, actually, so I had to add these tiny heatsinks. By comparison, the CPU and TED are not all that hot. The voltage regulator, on the other hand, is a little toasty. Alright, so from here, I will change the orientation of the camera so that you can see what's going on screen. Suffice to say that the SID audio seems to be working just fine. Well, this took some effort. But now, hopefully, I've got a picture that I can work with here. Trying to get a good lock is difficult. Please do not be offended. This was one of the few items that could do digital audio on the Plus 4 with the SID chip. Oh, actually, this wasn't it. This one is it. Okay, so now I'm curious. This is the PAL Crystal and PAL firmware. And we'll run that Guyana demo again. So this is the Guyana demo on a PAL TED machine with a SID card. Here's the NTSC one. I don't know if the demo will run, but we'll see. Oh, it didn't like that at all. In fact, it was a little bit slower, and then it just crashed. Well, let's try again. We'll try that. This one again. Oh, that is not happy. It is not happy. Alrighty. Let's try something else. Well, that's encouraging. This doesn't sound any different. The game is supposed to behave slightly differently in NTSC, but it is still supposed to behave. Now, this is a very different soundtrack than the one that is on the pure TED version. Looks like they have a slightly different version for NTSC because the audio sounds normal. The movement feels different, but they're probably accommodating the slightly faster frames on the NTSC version. Alright, maybe now that I have a working user port. Let's see what this is. There we go. That's interesting. That is very interesting. I read somewhere that there was a problem with any Super Nintendo games that didn't read all 16 bits of the input from the joystick. This might be the case here. So because of my user port problem, I've gotten a little silly with this set of sockets over here. With this setup, I'll be able to exchange the 6529 part with the LS654 part and be able to add or remove a pull-up resistor depending on what kind of part is in there. And it was a good thing that I set aside a set of socket pins for pull-up resistors. I will explain when I do my joystick demonstration. The 6529, the original part, has built-in pull-up resistors, which is why we're supposed to omit these when we use this standard part. The other option is to use this, but it is not like the stock MOS part where it has built-in pull-ups, so you have to supply pull-up resistors. The current LittleSixteen version 4 uses an 8K resistor pack for that purpose. I have tried using lower values. This is a 4.7K resistor pack, which is the same thing used on the third joystick port if you have the SID option installed. And it's also used on the keyboard as a keyboard buffer. I tried using that in there as well. And then I have this janky third option here, which is two 4.7K resistor packs set up in parallel. And that was because I didn't have any 2.2K resistor packs handy. But when I measure across the pins, I do get 2.3 kilo ohms. So I'm going to use all three of these as a test to see which ones of these work better with the Tech Select SNES adapter. This guy over here. There's my Super Nintendo controller here. And I'm running a very simple version of Joyride that Sukopera tossed together for me here. So we got up, down, or pardon me, X, A, B, Y, right trigger, or right trigger, start, select, up, down, right, left, and left trigger. So this is working normally using the standard 6529 part that's built into the Commodore Plus 4. Next, let's try the substitute. All right, now we've got the LS654 part, actually an ACT 654 part. So up, down, right, left trigger. It's kind of oscillating a little bit between the X and the left shoulder pad. Okay, so right is alternating between the right shoulder pad and left shoulder pad. You see the numbers flickering there. A is very so slightly flickering. You can see the third digit barely. B is okay, Y is okay. X actually rapidly switches a little bit between X and A. Start is okay, select is okay. That is with the 8.2K pull-up or the 8K pull-up. We're going to try again with the 4.7K pull-up. Okay, this is with the 4.7K resistor pack. Okay, up, down, right, left trigger. It's shifting a lot more now between the left and I can't quite tell, I guess the X input. Right trigger is shifting a lot more between the right trigger and left trigger. A is alternating between an 8 and 0 in the third digit. X is alternating between X and A. B is good. Y is good. Start is good. Select is good. And since the effect seemed more pronounced, it occurred to me to use an even lower value for that resistor pack. And that's where the janky 2.3K resistor pack came from. So let's try that one. Okay, so with a 2.2, or right now effectively a 2.3 resistor pack, here we go. Up, down, right, left, still good. B. A is a lot more solid. You see the 8 there. X is also a lot more solid. Right trigger is very solid. Left trigger or left shoulder button is very solid. Select is working, start is working. So yeah, up, Up, down, left, right, diagonals, combinations work. So a lower value of pull-up resistor seems to work better. I don't exactly know what's going on, but I think that it being a lesser value, it can draw more current. It seems to respond quicker and it's a little more stable. I wish I knew the exact circumstances behind this. So that'll be one of a couple recommendations I'm going to make for changing the bill of materials. So yeah, this resistor pack hack is a little janky. I am not going to keep that. I'm going to get a proper set of 2.2K resistor packs for both of my builds. I'm also going to remove this goofy socket layout here. I've done all of my testing here and I think this will be fine. I am using a slightly modified version of Petsky Robots for the Plus 4 that reads all 16 bits of the input stream from the SNES controller. This makes it more compatible with third-party controllers, according to the designer of a third-party version of the TechSelect adapter. If Jim Wright is watching this, would you consider making an updated version of this for the Little-16? The Little-16 has a SID chip and 512 kilobytes of RAM, although the majority of Plus 4 applications that use the extra RAM only use 256K of it. Double kill. That guy hits real hard. Yeah, there we go. Terminated. Yep, they're all dead.
While this is pretty fanciful for a Plus 4 version of the Attack of the Petsky Robots, I would love to see this for the Little-16. On the next episode, we will put this into its case and we will retro-bright those keyboards that we got from Hungary. Until then, good day.